All right, final section of chapter 3, one-to-one and inverse functions. So there's a particular type of functions that are cooler than any other functions. They are one-to-one, and if you are one-to-one, you're super cool and you get an inverse. So a one-to-one, a regular function, you put one in, you get one out. A one-to-one function is that thing that you got out, there's only one way to get that thing. So something that's not a one-to-one function is our absolute value. Absolute value is not one-to-one because if we put in 1, we just get 1 back. But there's more than one way to get 1 out of an absolute value function. We could get it here, or we could get it over on this side. So it is not a one-to-one function. A way you can check if it's a one-to-one function is if it passes our vertical line test. So this totally passes our vertical line test. However, it fails the horizontal line test. So it has to pass a vertical and horizontal line test. If we looked at our cubic function over here, it passes the horizontal line test. So x cubed is one-to-one. If we check our floor function, this one is super not one-to-one. If we took a look at its graph, it's down 2 a little bit, so it would probably be more like this, something like that. That's a bunch of horizontal lines. So if it's a bunch of horizontal lines, it's definitely not going to be one-to-one. So this one is not one-to-one. What's interesting is our squared function. You'd think it might be one-to-one and have a nice inverse, but our squared function is also not one-to-one. So it fails our horizontal line test. What's kind of interesting is most one-to-one functions, their inverse, if they're one-to-one, then they get an inverse. Inverses are really cool because they undo each other. We have to kind of mess with our squared function when we do its inverse of square root. That's where that goofy plus or minus comes in, because it doesn't quite work for squaring and square roots to undo each other. So that's why we kind of always easily forget that plus or minus, because it's not quite intuitive compared to other inverses like multiplying and dividing, logarithms and exponents. So if you are a one-to-one function, you get this thing. You get a cool thing called an inverse. Inverses are really cool because they undo each other. They're functions that reverse their processes. To find them, you're going to do the following steps. So you are going to swap the x and y values, which is not a legal thing. You're just going to take them and you're going to straight up swap them around. You're going to solve for y. Then your original's range is the domain for the new. Because if you're swapping your x and y values, you're really also swapping the domain and range for your two functions. And then step 4, you have a little scoop of ice cream for yourself. So let's try this out. Let's find the inverse and its domain and range. So first thing I like to do if I'm trying to find an inverse is I replace f of x with a y, because that's all f of x is. It's really just a fancy way to write a y. Now I'm going to create the inverse. So this is the original function. I'm going to create the inverse by swapping the x and y variables. So those two equations are not the same equation. The blue one is the original function, and I've actually technically already found the inverse right now. That purple x equals 7y minus 3, that is our inverse, but it's not written really nice. So I want to get the y value by itself so I can write it nicely. I'm going to add a 3 to both sides. So I get 7 plus 3 equals 7y, divide by 7. All right, so now I've got y equals x plus 3 over 7. So now I can write my inverse in a nice way. We write it like this, f with a little -1 inverse thingy next to it. That's how we know that this new function that I've made is related to the original one, that they are inverses of each other. And this is our sort of inverse symbol. X plus 3 over 7. Now we're going to talk about its domain and range, which is going to be a little goofy for this one. This is a linear function. So if I looked at the original graph, it'd be something like that. You know, it's a linear, it's going up, all that jazz. If we checked its domain and range, it's negative infinity to infinity. There's no problems with our domain and range for this thing. And you can check that in your happy function book. If you look in your happy function book for a linear, it's always just negative infinity to infinity for our linears. If I want to find out what the domain and range of my inverse function is, all I have to do is swap those two around for my inverse. You might notice the problem with that is if we swap them around, they're exactly the same. Whatever. So, but we'll still write that down so I know that you know that I know that it's the same thing. So now I've got my original function and I've got my inverse. We've identified the domain and range of both. Let's do another one that's hopefully a little more interesting. This one, g of x is the square root of x minus 1. All right, cool. So I am first going to rewrite it so it looks a little bit better. G of x, again, that's just a y. Okay. And now I need to find my inverse. To find my inverse, I swap x and y to create a new function. There it is. I have found the inverse. Wonderful. But it doesn't look nice, and I like it to look nice. So I'm going to make it look nice. I'm going to square both sides. Let's see, that equals y minus 1. So add a 1. So y equals x squared plus 1. If I wanted to write it all pretty, I would write g inverse, g negative 1 of x equals x squared plus 1. All right, let's take a look at what our domain and range is. I'm going to start with g of x. So that's a minus 1. So that's as if we took our regular square root function and I moved it over 1. So it would look like that. Normal square root function is from 0 to infinity, but this has been moved 1 to the right. So now my domain is going to be 1 to infinity. Its range is going to be from lowest it goes is 0 to infinity. And I can see that based on the graph. If you can identify that in your head, that's great. But I'm just looking at the graph in order to figure out that domain and range. Just making a real quick rough graph. If you wanted to, you could also graph it on your graphing calculator to take a look at the graph of the function. That's the easiest way to find them for this one. For domain restrictions, you could do all that jazz. But the range, grab this thing, look at the graph. All right, anyway, on to our inverse. Our inverse, we're not going to look at the domain and range of a quadratic. Instead, all we're going to do is we're going to reverse these again. So the domain and range of this thing, its domain is the range of the original function. So 0 to infinity. Its range is the domain of the original function. So 1 to infinity. What's interesting is then if you look at the graph of it, I'll even graph them on the same spot, it's only half of a quadratic. It's not the whole thing. It's just a piece of it instead of the whole U shape. And that's because it's an inverse. It's not a regular quadratic. It's an inverse of this square root function. It loses some of its quadratic properties since it's an inverse. But that's all you gotta do. You swap the x and y and solve, and then you swap the domain and range. That's it. Look at the graphs. It's all good. All right, sweet. Bye.